Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. At the heart of all networking lies a fundamental question: how do we move signals from one device to another? Transmission media provide the answer. These physical or wireless pathways carry the signals that make digital communication possible. Whether it's data moving from a desktop to a switch, a server streaming video to a user, or two routers exchanging packets across long distances, all of it depends on transmission media to deliver that signal intact and efficient. It's the very first layer, the physical layer of the OSI model, and the starting point for all networking designs. The Network Plus exam places strong emphasis on transmission media. You'll find questions related to copper cabling, fiber optic systems, and even wireless technologies under the physical layer objectives. The exam expects familiarity with cable types, categories, connectors, signal limitations, and installation best practices. These questions often show up in wiring diagrams, installation scenarios, or troubleshooting questions. Understanding the foundational role of transmission media helps you interpret these scenarios more confidently and make informed decisions in both exam and real-world environments. There are three primary categories of transmission media: copper, fiber, and wireless. Each has its own unique strengths and is chosen based on the physical environment, performance needs, budget, and compatibility. Copper cabling is the most widespread, known for its affordability and ease of use. Fiber offers higher bandwidth and longer distances with strong immunity to interference. Wireless adds flexibility and mobility, but typically at the cost of speed and reliability. The choice of media is never random. It is always matched to the needs of the environment. Among these, copper remains the most commonly used physical medium in local area networks. Copper cabling carries electrical signals from one endpoint to another using twisted pairs of wire. It's used to connect workstations, printers, servers, and access points to the network infrastructure. Copper is also used in many legacy systems, such as telephone lines and early Ethernet networks, though modern versions have evolved with better shielding and bandwidth capabilities. Despite the growth of fiber, copper continues to dominate at the access layer of most networks. Unshielded twisted pair, or UTP, is the most prevalent form of copper cabling in modern networking. Found in nearly every office or home network, UTP consists of pairs of copper wires twisted together without any additional shielding. The twisting helps cancel out electromagnetic interference by ensuring that each wire in the pair picks up similar amounts of noise, which can then be canceled during signal processing. UTP is used in Ethernet cabling across categories such as Cat5e, Cat6, and Cat6a. Shielded twisted pair, or STP, builds on UTP by adding a layer of shielding around each pair or around all pairs collectively. This shielding is typically foil or braided metal and provides additional protection against electromagnetic interference. STP is especially useful in environments with high electrical noise, such as factories, hospitals, or areas with heavy machinery. While more expensive and slightly harder to install than UTP, STP's noise resistance can improve reliability and signal clarity in noisy installations. Copper cabling has certain physical characteristics that influence its performance. It is susceptible to electromagnetic interference, especially when run parallel to power lines or near motors. Its maximum effective distance is limited, typically no more than 100 meters for Ethernet applications, after which signal strength drops and performance suffers. However, copper cabling is much cheaper than fiber, both in terms of materials and installation. This makes it a go-to choice for short to medium-length runs in cost-sensitive environments. The gauge of the wire used in copper cabling is measured in American wire gauge, or AWG units. Lower AWG numbers represent thicker wires. For example, 22 AWG is thicker than 24 AWG. Thicker wires generally support longer transmission distances because they offer lower resistance and less signal attenuation. However, they are also less flexible and harder to work with in tight spaces. Choosing the right gauge is a balance between distance requirements, signal strength, and ease of installation. Crosstalk is a form of interference where a signal transmitted on one pair of wires creates an undesired effect on another pair. This is a common concern in copper cabling, especially when multiple cables are bundled tightly together. Near-end crosstalk occurs close to the signal source, while far-end crosstalk happens further along the cable. Both can degrade signal quality. Twisting the pairs at specific intervals and using shielding in STP help mitigate these issues, but proper cable spacing and termination are also critical. Cable standards are crucial for ensuring compatibility, safety, and predictable performance. Standards such as those from TIA/EIA define how cables should be constructed, tested, and rated. These standards ensure that a Category 6 cable from one manufacturer performs the same as a Category 6 cable from another. They also specify connectors, jacket types, wire gauges, and performance benchmarks. Following these standards is not optional. It's essential for ensuring that networks operate as intended and that future upgrades remain compatible. Copper cable categories are defined by their performance characteristics. Cat5 and Cat5e are older standards that support fast Ethernet and gigabit Ethernet respectively. Cat6 adds improved shielding and tighter twisting to support 10 gigabit Ethernet over short distances. Cat6a enhances this further with full 10 gigabit support up to 100 meters. Higher categories like Cat7 and Cat8 exist, though they are often used in specialized data center environments. Each category is backward compatible with the standards before it, but performance is limited to the lowest rated component in the link. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. When it comes to Ethernet networking, the type of cable used directly impacts the maximum speed that can be achieved. Each Ethernet standard, such as 100 base to 1000 base or 10G base, has a minimum required cable category. For instance, Category 5E, Cat5e is the minimum recommended standard for gigabit Ethernet, and it can support speeds up to 1 Gbps over typical distances. To achieve 10 Gbps performance, you'll need at least Category 6A, Cat6a cabling, which includes improved shielding and tighter twists to minimize crosstalk and support the higher frequency signals required by the faster protocol. In addition to speed capabilities, different cables come with different jacket ratings depending on where and how they are installed. Polyvinyl chloride, PVC, jackets are common for general-purpose cabling and are often used in open office environments. However, PVC emits toxic smoke when burned and should not be used in air handling spaces. For those scenarios, plenum-rated cables, which have low smoke and fire-resistant properties, are required. These are labeled CMP, Communications Plenum. Riser-rated cables, CMR, are used for vertical runs between floors and offer fire resistance suitable for those spaces, but are not safe for air handling ducts. Copper Ethernet cabling has a defined maximum distance, and that limit is 100 meters for most standards. This includes the total length of both the horizontal run, from patch panel to wall jack, and the patch cables at either end. Exceeding this limit can lead to signal degradation, increased latency, and packet loss due to attenuation. This 100-meter limit is not just a best practice, it's an industry standard, and exceeding it without signal boosters or extenders will often result in unreliable performance, especially at higher data rates. When installing copper cabling, physical handling is just as important as selecting the correct type. Tight bends, sharp angles, and excessive pulling force can damage the cable's internal geometry and disrupt the twist rates of the wire pairs. This can result in degraded performance or even complete failure of the link. Installers should also maintain separation between Ethernet cables and high-voltage electrical cables to minimize the risk of electromagnetic interference, EMI. EGMI, using cable trays, raceways, and proper supports, helps preserve cable integrity and simplifies future maintenance. Understanding the distinction between patch cables and horizontal cabling is important for both installation and troubleshooting. Patch cables are short, flexible Ethernet cables used to connect end devices like PCs or IP phones to wall jacks or to connect switches to patch panels. They are built for flexibility and frequent handling. Horizontal cabling, on the other hand, is installed through walls, ceilings, and conduits as part of a structured cabling system. It typically terminates at patch panels in a telecommunications room and is designed for permanence and performance rather than flexibility. In structured wiring systems, horizontal cabling follows predefined paths and is terminated at central points like patch panels and wiring closets. These systems offer many benefits, including easier identification of faults, organized infrastructure, and the ability to reconfigure or expand networks without needing to rerun cables. Patch panels allow for flexible connections between the structured cabling and the network hardware, and they make it possible to trace connections clearly using labeling systems and documentation. Proper labeling is a critical component of structured cabling and copper installation. Each cable should be labeled at both ends, identifying the patch panel port, wall jack, or device it connects to. This documentation simplifies troubleshooting, supports efficient changes or moves, and helps ensure compliance with industry best practices. A well-documented cabling system not only speeds up support response time, but also enhances safety by clearly indicating which cables are active and which may be repurposed. You can expect a range of questions about copper media on the Network Plus exam. These may ask you to match cable categories with supported Ethernet speeds, identify appropriate jacket types for certain environments, or determine when to use shielded vs unshielded cable. Other questions may present a network diagram and require you to identify where structured cabling is used or where maximum length limits have been exceeded. Installation issues such as improper bend radius or missing cable labels may also appear as part of troubleshooting scenarios. In summary, copper cabling remains a cornerstone of physical layer networking. It is affordable, versatile, and relatively easy to work with, which is why it's still widely used even as fiber adoption increases. Understanding the different cable categories, shielding types, performance ratings, and installation best practices is critical for building and maintaining reliable wired connections. Whether you're supporting an office network, planning a structured wiring system, or preparing for your Network Plus certification, mastery of copper media will serve as a lasting foundation. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.